Now we know how to name molecular compounds, those that are sharing their electrons. So you have two nonmetals sharing electrons. Now let's learn how to name ionic compounds. So ionic compounds are ones that form ionic bonds, meaning one element loses electrons while the other gains those electrons. So it's a give and take situation rather than a sharing. And this is going to happen between a metal and a non-metal. Okay, so the way we're going to draw Lewis dot diagrams is going to be a little bit different because before we represented the sharing of the electron. So we drew a line to represent that sharing and that bond. But with ionic, we need to show the transfer. We need to show one element losing electrons while the other gains those electrons. Okay, so let's take a sodium atom and have it bond with a chlorine atom. Okay, so sodium has 1 valence electron. Chlorine has 7 valence electrons. We learned how to do those valence electrons on a single atom several lessons ago. So when we go to draw it out, we need to show the transfer. So what happens is this sodium has this one that it wants to get rid of, and then once it gets rid of that, the next energy level below that will be full, so it'll be similar to one of those noble gases. And if it gets rid of this electron and gives it to another element, then this element, who has 7, would then have 8 and would be similar to the noble gas. So they would both be happy because they would have full outer energy levels. So when that happens, when that transfer happens, Na now has no dots on it and gets a plus sign. Because remember, when you lose and negative, you become a little bit positive. And then we draw the chlorine with 8 dots now, and we give it a little negative sign to indicate that it has that extra electron because it gained that negative. Okay, so here's another example where we use 3 elements. So 1 calcium with 2 chlorines. Calcium has 2 valence electrons. Both of the chlorines each have 7. So when all 3 of these come together, that calcium can give one of the chlorines an electron, and it can give the other chlorine electron. It now has that next inner energy level full, and then both of these now have that outer energy level full, and then we would draw them with each chlorine having a negative because they each only gained 1, but the calcium gets a 2+ because it lost 2, so it now has a positive 2 charge. Okay, so that's how you would draw your Lewis dot diagrams. You'd have to show where those electrons came from and where they went. All right, how do we name them? Let's do some nomenclature. So there is a different set of rules for naming ionic bonds. Okay, so let's say you need to write the formula. You're given the name, you need to write the formula. Okay, you're going to write each ion. The cation comes first. So the one that becomes positive comes first. So that means the metal comes first. Then the non-metal comes second. Okay, and now we need to worry about those charges because those charges are where it's all at, right? We're keeping track of electrons, and electrons have a charge. Okay, when we go to write these formulas, the overall charge of the atoms must equal 0. Okay, and I'll do some examples to show you. But if the charges of your 2 items cancel out, so they're already equal, then you simply write the symbols, and you don't have to worry about those numbers. Okay, if not, if your charges of your 2 items do not cancel out, then we need to use subscripts to balance out the charges. Okay, and if we are using polyatomic ions and we have to have more than 1 polyatomic ion, we have to put it in parentheses and put the subscript on the outside of those parentheses. And I'm going to show you an example, okay? You should have printed out your polyatomic ion chart, I hope, and keep it in the same place that you keep your printed periodic table because you're going to be using it quite a bit from now on. Okay. If in the name that you've been given, if you see a Roman numeral, Roman numerals are used to indicate the ion's charge. So I'm getting ready to show you the patterns on the periodic table of the charges that these elements have, but some elements, their charge changes depending on their interaction, so you can't just automatically know it. So in order to know it, we have to represent it, and we use Roman numerals for that. So make sure that you know your Roman numerals. All right, let's say we're doing the opposite. So you're given a formula, you have to provide the name. So you're going to write the names of both ions. The cation still comes first, so the metal still comes first. If you have a monatomic ion, so just two elements in your compound, you're going to change the ending to ide, okay, IDE, just like we did before, okay, so that's similar. But if you have a polyatomic ion, polyatomic ions have special names, and you don't change it. You just write the name of the polyatomic ion if you have one. And we're going to use Roman numerals to show the ion's charge if more than one is possible, because our overall charge must equal 0. Okay? So those are the rules. Now you know them. Let's figure some things out. Let's see how this is going to work. Okay, so first off, whenever we're doing one of these, we need to consider a couple of things. One, if you're trying to figure out the name of something, where are you going to find the name, right? You're giving chemical symbols. Well, if the name ends in IDE, that means you only have two elements, so you look at the periodic table to find your chemical symbol. Okay, if the name you've been giving ends in ate or ite, A-T-E or I-T-E, that means it has more than two elements, and you need to find it on your polyatomic ion chart. Okay, so if you look at your chart, you'll see that all of those end in ate or ite, so you just use their name. Okay, what charge? If it's a polyatomic ion, your chart tells you what charge. Or you can look on your periodic table for the pattern that we're getting ready to go over for your single elements. And then sometimes you'll have to look at the Roman numeral that's been given. But a big thing to remember is that there are no prefixes in ionic compound nomenclature, okay? I know that we did a lot of prefixes in the last one because that's part of covalent bonding rules. Okay, they have the prefixes. There are no prefixes in ionic bonding. Okay, so let's look at our periodic table pattern. So you may want to add these numbers to your periodic table that you printed out. Okay, those that exist in column 1, they have a positive 1 charge because they have 1 electron in that outer shell. And so it's much easier for them to give up that electron to some other element than it is for them to try to gain 7. So they take on a positive 1 charge because they like to get rid of that electron. Okay, the second column, 2. They have a positive 2 charge because, again, it's easier for them to get rid of those 2 extra electrons than it is for them to try to gain 6. The transition metals, transition, so you'll need Roman numerals for those. Okay, over here, the 3A column, they take on a positive 3 charge. They like to get rid of those 3 extra electrons. This column varies. This column takes on a negative 3 charge. They like to pick up 3 extra electrons. This one likes to pick up 2 electrons, become negative 2. And this one is negative 1. It likes to pick up that 1 electron. Okay, so this is your pattern. 1, 2, 3, skip 1, 3, 2, 1. Okay, so if you are using these elements, you should know their charge because you can look at the periodic table to tell you. Okay, so if I were you, I would add these yellow numbers I have here to that periodic table you printed out. So you can use that as a reference. Okay, and remember the noble gases, they don't gain or lose. They are noble. They don't interact with a lot because they have a full outer shell. They're very stable. Okay, there is one of the transition elements that never changes, and that's silver. Silver is always a +1 charge. Okay, so it likes to lose 1. So that's a special exception to those transitions. All right, let's do some examples. Okay, so we have potassium chloride. I know that I need to use my ionic naming rules because potassium is a metal, and covalent is 2 nonmetals. So potassium is a metal, so I'm going to use my ionic naming rules. I'm going to look at my periodic table and say, what is the symbol for potassium? It's the letter K. And now what is its charge? If you're looking at your periodic table, which I hope you are, you'll see that potassium is in the very first column, and we just said that that column takes on a +1 charge. Okay. Next is chloride that ends in IDE. That means I'm not using a polyatomic ion. I'm just using my periodic table to find chlorine, and that is in the next to last column. So we just said those ones like to take on a -1 charge. Okay, so that's what I'm going to write down. I'm going to write down a K with a plus sign to be +1. I'm going to write down a Cl with a minus sign to mean -1. Okay, now I'm going to compare these two charges to see if I need any subscripts. Okay, +1, -1 cancel out. +1 -1 equals 0. So that means I don't need any subscripts. So my final answer is KCl. Okay, now let's look at the next one. We have magnesium, that's Mg, that's on the periodic table, and it is a +2 because it's in the second column. Now the next one says nitrate, ATE. That means it's a polyatomic ion. So I have to go to my polyatomic ion chart and find nitrate and see what it is and what its charge is. And I find that it is NO3 with a -1 charge. Okay? All right, so now I know who I've got. Now I have to check those charges to see if they cancel. Here I have a +2 and a -1. Those do not cancel off. They do not equal 0. So in order to write my final formula, all I have to do is crisscross. Okay, that's what I say, crisscross, which means that this number 2 over here is going to come down to over here, and my -1 is going to come over here. So my final answer is Mg with a 1, but it's understood, so I don't write it. And then I need 2 NO3s. So remember just a few slides ago in my notes, I said that you have to put polyatomic ions in parentheses if you need an extra. Okay, so this means 2 NO3s. If I just put the 2 there without parentheses, that turns into NO32, and that's something totally different than 2 NO3s. Okay, but now they cancel out because remember this magnesium is a +2, so I have 1 +2. This nitrate is a -1, but I have 2 -1s, making it -2, so they cancel now. Here's one that has that Roman numeral. This Roman numeral tells you copper's charge because copper, if you look on your periodic table, is a transition metal, so it can change its charge based on who it's interacting with. This lets you know copper's charge is 2. And then chloride ends in "ide", so that's chlorine, so I find that on my periodic table. It is always a -1. Okay, so my copper is a +2. My Roman numerals told me so. Cl is a -1. They don't cancel off, so I'm going to have to crisscross again. So it's going to be Cu, understood 1, Cl2, because I crisscrossed. Okay? So this can be pretty tough for a lot of students. So if you are completely lost right now, if you have no idea what's going on, please get into contact with me so we can have a one-on-one meet and I can help you through this. A lot of students, it's the crisscross. They don't understand the crisscross. They don't understand where the number's coming from. And that is okay if that's where you are. You just got to let me know so I can help you, okay? Some students get this right off and you're good to go, and that's okay too. So but if you need help, you got to let me know or I'm not going to know you need help. Okay, so this is when you're given the name, going to the formula. Let's do the reverse. Okay, you're given the formula, you need to write the name. Okay, so here we only have 2 elements, so I know I can stick with my periodic table. Okay, the first element is Na, so I find that and I see it's sodium. Sodium is in the first column, so that means it follows that regular charge pattern. I don't have to use a Roman numeral. The second element is Br, that's bromine. And since I have only 2 elements, I'm going to change the ending to IDE. So it's going to become sodium bromide. Okay, next up we have Na, that's sodium again. And we just said when we use sodium, we don't need a Roman numeral because of its location on the periodic table. And then we have CO3. So since I have more than 2 elements here, I need to use my polyatomic ion chart. And I need to look up what is CO3 called. And since it's a polyatomic ion, we do not change the ending. We just write down its name directly from the chart. So this is sodium carbonate. Okay, see I didn't change the ending from that chart. I just kept it the same. All right, third example, we have Fe. So I find that on the periodic table, and that is iron. Now, iron is a transition metal. It's not in one of those columns that follow a pattern. That means I need a Roman numeral to indicate its charge. But how do I know what its charge is? The formula tells you. So just how we had to crisscross to get our subscripts on the previous slide, here we crisscross to figure out our charge. So since iron is over here, if we were to cross, we get this 3. So that 3 is the charge of iron. So this is iron 3. Okay, and we can check because there's a little 1 right here, which would mean that chlorine's charge is 1. If we look at the periodic table, we see its location. It is 1. So I'm crisscrossing correctly. Okay, we only have 2 elements here. So we have iron and chlorine. So again, I need to change the ending of that second one. So this becomes iron 3 chloride. Okay, I have to use this Roman numeral here because iron is a transition metal. Okay, so I put that in that Roman numeral 3 in parentheses. Okay, so it's time for some independent practice. So, like I said, if you are lost, if you are confused, if you have no idea how to do this, just get into contact with me. We'll work together. We'll get you where you need to be, okay, for that practice.